Everybody good? All right, next one. If a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, that means we're going to ignore the fact that there's air resistance. Its height, s, in feet above the ground, t seconds after projection is given by, there's the formula, h equals negative 16t plus 100t. If you're taking physics, or if you have taken physics, you're probably used to seeing that formula, although most of the time in physics you use meters and not feet, so it's a little different, but it's the same formula. A, after how many seconds will the projectile be 50 feet above the ground? And then B, how long will it take for the projectile to return to the ground? All right, so for A, we just want to see how long is it going to take for the height to be 50. So I'm just going to take this formula and I'm going to plug 50 in for my height. So that's going to be 50 equals negative 16t squared plus 100t.
Then you could add the other two on the right over that way.
That's what I'm
positive.
I'm with you. Let's move these to the other side so that the lead coefficient is positive. So it's going to be 16t squared minus 100t plus 50. Okay, so before we just launch into solving this by bottoms up method or whatever, I'm pretty sure it factors. Maybe it doesn't. I don't know. Pretty sure it does. But before I do that, all of those numbers are divisible by 2. 50 is not divisible by 4.
Oh.
But they're all divisible by 2, and I would go ahead and do that. It just makes your life easier because it makes the number smaller. So I'm going to do that first. Since I'm not real sure, I'm pretty sure. So I'm just going to divide everything by 2. Technically, I'm dividing the 0 by 2, but 0 divided by 2 is 0. So that gives me 8t squared minus 50t plus 25. All right, well, let's just say I don't want to try to figure out the... Oh, I think it's 400 again. Let's just factor it. It factors. So I'm going to multiply first and last. Right? Because let's see, that's 200. Yeah. So drop the lead coefficient. Replace. Well, maybe it doesn't factor. 200. Oh, why did that happen? Oh, hold on, I know. My computer timed out. Okay, so how do I make it not do that? I wonder. No, I lied. It doesn't factor. Maybe it does. I don't know. Let's use a quadratic formula. If you can't factor it or you can't think of the factors, are there any factors of 200 that combine to give you 50? Let's see, 40 and 5, no, 50, no. 20 and 10, I don't think so. So, we'll use a quadratic formula. Everybody know it? Quadratic negative b minus the square root b squared minus 4ac over 2a. All right, so negative 50. They are. I think in the end it'll be okay though. Let's see.
Be some simple number like 2.
Well, that's what I was going to say. I mean, it may factor, but
A is 8, right? Because we're like.
Yes, A is 8. So I'm going to use the green numbers because they're not as big as the orange numbers. So I'm going to use those instead. My negative 50 becomes positive. just keep simplifying. So 2,500 minus 800,
1300. Wait, no,
1,700. Okay, well 17 is prime, but 100 is not. 100 is a perfect square, right?
Mhm.
So if it's a perfect square, that means the square root of 100 is 10. That's going to come out to the front. And the 17 will stay underneath. You can break it down like we've been breaking down. You can break it down 17 and 100 if you want to. That's exactly what I just did. I just did it in my head.
50.
So then don't you split it?
So I
into
have
fractions?
50 plus or, yes, because they'll simplify. 50 plus or minus 10 square root 17 all over 16. You can split that into two fractions, 50 over 16 plus or minus 10 square root 17 over 16, and then simplify. So that becomes 25 over 8 plus or minus 5 square root 7 over 8.
We went to 7 and
Oh, 17, I'm sorry. Thank you. Sometimes I can't read my own writing. Oh, don't worry. B is much easier.